Welcome to my channel. Jesse and Christine had one big dream. Simple on the surface, but deeply meaningful at the same time. They owned a quiet 8-acre piece of land in northern Ontario, deep inside the boreal forest. And instead of hiring a crew to build on it, they decided to do it themselves, with their own hands, from the ground up. The land is stunning. Trees everywhere. The kind of place where you actually feel calm the moment you step onto it. The kind of spot that makes you want to build something that lasts. But before any of the exciting parts could begin, there was a lot of unglamorous work to get through first. The fall before construction started, they focused on all the behind-the-scenes basics. Digging trenches for water and electrical lines, putting in a large septic tank, and building a raised septic field. It was messy, heavy, and exhausting, but it was absolutely necessary before anything else could happen. Once the concrete footings were poured and fully set, they moved on to building the foundation columns using sonotube forms. The footings already had rebar sticking up out of them, so they tied in additional rebar to create one solid connected structure running through each column. The tubes were filled with concrete, and brackets were installed with care to prepare for the next phase of building. Next, they moved on to assembling the outer beams. Before anything was lifted into place, every edge was coated with a liquid moisture barrier to protect the wood from the start. Then the beams were secured onto the brackets one by one. The whole process was methodical, fitting pieces together, tacking them in position, and getting everything lined up before final fastening. Everything at that point was about height, balance, and moving carefully. Once the truss was standing upright, they braced it firmly so it wouldn't shift. And the moment it was in position, their focus immediately moved to the next one. They started thinking about how to make the whole lifting process faster and more efficient going forward. They added temporary supports, reviewed their movements, and adjusted their rigging setup to make future lifts go more smoothly. Even with those improvements, it was still tough work. The frame shifted under its own weight. The top sagged a little, and the base didn't always want to sit where it should. But as more A-frames went up, something began to change. The whole structure started to settle and feel more solid. Once the frames were connected together, the movement stopped and real rigidity kicked in. The sheeting phase began with OSB panels. They started installing them from the lower sections of the A-frame and worked their way upward. The goal was to get the structure covered quickly enough to protect it from weather, but slowly enough to keep everything accurate. As each panel was added, the whole frame stiffened up noticeably. Every sheet nailed into place pulled the structure a little tighter and added strength from one end to the other. Once the lower walls were covered, Jesse turned his attention to the roof. He began laying down synthetic underlayment across the sloped surface. Unlike old-school tar paper, this material is lighter, easier to work with, and more breathable. But as he climbed higher, things got much harder. Ladders weren't enough anymore. The steep pitch of the A-frame meant every single move had to be slow and deliberate. Working at that height became a constant balance between getting things done and staying safe. So Jesse built custom roof jacks, metal supports shaped to match the angle of the roof, holding solid planks that created a stable platform to stand on. With that setup in place, they kept sheeting upward without losing their pace. Soon they were working on the upper rows of OSB, where everything felt more exposed and less forgiving. Each panel had to be carefully guided into position on that steep slope. Every step upward demanded full focus and attention. Then came the standing seam metal roof. The cabin stood about 35 feet tall at this point, and there was real doubt in the air. Not just about getting the installation right, but about something more basic. Could the two of them actually pull off a system like this on their own? The metal was already on site, stacked and waiting. And at that point, there was no going back. The roof panels arrived long and heavy, 35 feet in length and 16 inches wide, ready to be installed. They were designed to lock together with no exposed fasteners, giving the roof a clean, professional finish. But that kind of system has no room for mistakes. Once a panel is set, it stays exactly where it lands. They took their time lining up the first panel with the starter strip at the base. That step was the most critical of the entire process, so there was no rushing it. Once it finally clicked into place correctly, everything else followed from that one starting point. It basically set the direction for every single panel that came after it. The main challenge was controlling a 35-foot sheet of metal without bending or twisting it. It was long, awkward, and completely unforgiving. But once it was up there and they stepped back to look at the roof taking shape, that's when the full scale of the project really hit them. Jesse then turned to reinforcing the floor joists based on how much load each section would need to carry. Along the outer load-bearing edges, he installed triple laminated beams, while the interior sections were reinforced with double laminations. With the framing above done, the next challenge was underneath the cabin. The crawl space became their new workspace. They began attaching pressure-treated plywood to the underside of the joists to hold the insulation in place, essentially creating a sealed cavity within the floor system. It was not easy work at all. The space was tight, the ground was damp, and every sheet of plywood had to be lifted overhead, positioned correctly, and fastened. It was slow, uncomfortable, and much harder than it looked from the outside. In northern Ontario, temperatures can drop as low as -40 degrees. Without proper insulation, it doesn't matter how well the rest of the cabin is built, the cold will always find a way in. Jesse and Christine chose mineral wool insulation for the job. It's fire-resistant, doesn't absorb water, and pests tend to leave it alone. Compared to fiberglass, it holds its shape better over time, which makes a big difference in a climate this extreme. They installed it in layers, packing the joist cavities completely full. Doubling it up gave them a much higher thermal rating, meaning the floor could actually hold on to heat even when it was freezing cold outside. The work was dusty, but more manageable than expected. It didn't irritate the skin the way fiberglass does, though it still required careful handling. Warm air naturally moves toward cold air. Without a proper barrier, heat escapes fast. A well-insulated floor keeps that warmth inside, makes the living space more comfortable, and reduces how much energy it takes to heat the cabin in the first place. To keep moisture out of the floor system entirely, they laid down a heavy-duty vapor barrier across the full surface. It came in wide rolls that stretched across the entire floor area. Once it was all in place, it created one continuous protective layer between the warm living space above and the cold ground below. The final step was installing the plywood subfloor. Each tongue and groove sheet clicked into the next, locking together and creating a solid, flat surface. The difference was immediate. No more careful stepping along narrow joists. Now there was a real floor to walk on. To protect the incoming utilities, they built a small boxed enclosure out of pressure-treated plywood. This little box would act as a sealed channel, guiding both the electrical conduit and the water line safely into the cabin. With winters this harsh, even a single gap simply isn't an option. Everything had to be fully sealed and insulated. No exceptions. With the subfloor fully insulated and protected, the utilities were clean, organized, and ready. Everything was now transitioning from the brutal conditions outside into the warmer, protected interior of the cabin. After finishing the insulation, vapor barrier, and plywood flooring, Jesse and Christine moved into the next major phase, framing the end walls. It started with the bottom sill plate, which sets the base for everything that follows. A moisture barrier was laid over the plates first to protect the wood underneath. The framing wasn't just about structure. It was the stage where the cabin really started to feel like a home. Every stud, every opening, and every connection had a purpose. This was the point where decisions became permanent, where the doors would open, where the windows would bring in light, and how the entire living space would actually feel to be in. Not everything went perfectly the first time. While framing the header above the front door, they noticed something was missing. Some of the required king studs hadn't been included in the original layout. Work had to stop. Parts of the wall came apart and were reworked to bring everything back in line with the structural plans. Not ideal, but part of the process. In the end, it was less of a setback and more of a correction. Moments like that are a reminder that real-world building always involves adjustments. You figure things out on the spot while making sure the structure stays solid and safe throughout. Jesse covered the loft floor with plywood sheets, turning it into a solid, usable surface. Up until that point, it had just been open joists. Once the sheets went down, everything changed. It became a proper floor, something stable to stand on, move around, and work from. It added a whole new layer to the build, both physically and visually, and made the whole project feel more complete. Attention then shifted to the second story of the back wall. A large window was going in here, taking up most of the wall space. They took their time measuring and marking everything precisely to make sure it all lined up exactly as designed. The sheathing started in the bottom corner where full sheets could go up with barely any cutting needed. They used OSB again, the same material as on the roof. Each sheet had to land exactly on the studs. If a seam didn't line up correctly, work stopped and it was fixed before anything was fastened down. Even something as small as leaving a slight gap between panels matters. That tiny space gives the material room to expand and contract with moisture changes, preventing warping or buckling over time. Windows and doors added a whole new level of complexity to the sheathing process. The goal was to keep the panels as large as possible rather than cutting them into smaller pieces. Bigger continuous sections around openings make the wall significantly stronger than piecing it together with smaller patches. To make that work, they lifted full sheets into place first and traced the window and door openings directly onto them. It was faster and more accurate than measuring everything ahead of time. Once the lines were marked, the sheets came back down, got cut, and went right back up, fitting cleanly around every opening. Row by row, the sheathing worked its way upward. The first few rows went on easily from ground level, but as the height increased, things changed quickly. At that point, a lift became essential. What would have been slow, awkward work on ladders turned into something much more manageable. Thanks to the lift and everything learned from working on the back wall, the front wall went up noticeably faster. Even with all the openings to work around, the process felt more efficient. There were still a few tight spots where smaller filler pieces couldn't be avoided, but they were placed with care so the strength of the wall wasn't compromised. By the second day, the finish line was finally in sight. Just a few last pieces remained on the upper sections, and the whole thing was about to come together. For the first time, the cabin was completely wrapped in solid panels, and that changed everything. It no longer felt open or temporary. The hardest part was behind them. The house was up, the walls were standing, the roof was on, the main structure was complete. There was still plenty of work ahead, but the biggest milestone had been reached. The project moved into a new phase, less about structure and more about protecting everything already built and making it livable. That's where the weather-resistant barrier came in. It was applied over the sheathing to stop wind and water from getting into the walls while still allowing any moisture from inside to escape outward. Without it, rain, snow, and cold air could slowly damage the structure from within. At the same time, attention shifted outward to something more personal, the front deck. It brought a different kind of energy to the project. Easy to picture slow mornings with coffee, quiet evenings listening to the trees, and simply sitting outside, feeling completely at home. This phase was less about structure and more about the life that would unfold here. The deck was designed to span a full 24 feet, extending evenly out from the center of the cabin. To achieve that, sections of lumber were laminated together to build up the strength needed to carry the load. As the frame came together, blocking was added where needed to keep everything tight and solid. Jesse and Christine added a border along the edges of the deck, and it made a bigger visual difference than expected. That one detail gave the edges a clean, finished look and made the whole deck feel intentional and complete. It meant going back and adjusting a few things. Some boards were recut, and extra blocking was added underneath to properly support the new layout. Extra steps were also taken to protect the deck framing from moisture damage. The beams were treated first with a moisture-resistant coating, followed by a layer of ice and water membrane applied over the key areas, wrapping across the joists and beams for added protection. What had been a bare frame slowly turned into a solid, walkable surface. The deck boards went down one by one, and with each piece, the progress was easy to see. They paid close attention to spacing, knowing the wood would expand and contract through the seasons. Some boards were set a little tighter, others given slightly more room, all to keep the lines looking even and consistent across the entire deck. Then came another major milestone, installing the windows and doors. Getting them into place wasn't easy. They were heavy and awkward, and every move had to be slow and controlled just to keep everything aligned properly. Next came the front door. With extra help on site, it turned into a careful, coordinated effort, lifting, guiding, and slowly adjusting it into position. Every edge and corner had to be perfectly aligned before anything was secured. Up until that point, everything had been focused on the front of the cabin. But once they really looked at the back, it was clear it couldn't stay as it was. Before the back deck could even begin, the foundation needed to be extended to properly support the additional load. That meant adding 3 more concrete sonotubes. Each one was carefully lowered into place, adjusted, and checked repeatedly to make sure it was perfectly level. Rebar was driven into each tube for strength, and concrete was poured to lock everything in permanently. Beam brackets were then set into the concrete using anchoring epoxy. Some of the hardware didn't match perfectly at first, so a bit of creative problem-solving was needed. The brackets were wet set into the concrete and carefully adjusted while it cured to get the alignment just right. The final step in that phase was tying everything together with laminated plates that spanned across every joint. Each piece was cut to cover about 4 feet total, overlapping on both sides of every splice so the load spread out properly across the whole system. With each layer added, the structure tightened and became noticeably more rigid. What had started as separate framing sections slowly became one continuous, heavy-duty beam system. Even without the finishing layers in place yet, the strength was already obvious. All the openings were prepped ahead of time for installation. Waterproofing was applied, and the surfaces were shimmed and adjusted so every frame would sit correctly. The conditions outside weren't ideal. Snow and cold made everything a little harder, but the focus stayed the same. Get everything ready so the actual installation could happen quickly and cleanly. With the A-frame fully closed in and winter firmly setting in outside, the focus finally moved indoors. The first step inside was installing roof baffles along the rafters, running the full length from the bottom all the way up to the peak. These baffles created a continuous ventilation channel, allowing air to flow freely through the entire roof assembly. The key idea here is ventilation. By keeping an air gap behind the insulation, moisture is prevented from getting trapped inside the roof system. Air can travel from the bottom to the top continuously, keeping the assembly dry while still maintaining strong thermal performance. As the insulation rolls started going in, the reality of the build set in differently. The cabin moved into a completely new phase. It was no longer just a shell standing against the weather. It started to feel like an interior space, a real room taking shape. From here on, all the work would shift toward finishing, running heat, wiring everything in, and slowly turning it all into a proper, livable home, while winter continued to build up outside. The journey isn't over yet. This is just the beginning of a new chapter. The structure is standing strong, but turning it into a real home, with all the interior work, the finishing details, and the personal touches, that all still lies ahead.